Hello again. Today we're going to talk about some science. Time travel? Do you want to change what you ate for breakfast? Well, it may be possible with these theories. What's your take on going back in time? I think everything that I've learned from the past and everything that I learn each day is an excellent thing. But if I can go back in time, no, I would not. Then I don't know if I would have met my wife. So anyway, here's some theories on time travel. Einstein's theory of general relativity is a true masterpiece in the world of physics, and lucky for us, it provides the foundation for understanding the possibility of time travel. In a nutshell, Einstein's theory states that time and space are interconnected, sort of like two turtles doing it, forming space-time. Imagine space-time as a giant trampoline with massive objects like stars, planets, creating dents in the fabric of reality. These dents of gravitational fields cause objects to move in a particular way through space and time. Now, let's say you wanted to time travel. According to general relativity, it's theoretically possible to manipulate those gravitational fields to create a shortcut through space and time, essentially bending it to allow you to travel back in time. It's like creating a wormhole or a tunnel through space and time. But before you get too excited about the prospect of hopping into a DeLorean and heading back to whenever you think the golden age is, there are some significant obstacles to overcome. Of course, the most obvious one is being we don't have the technology to do that yet. And equally important, though less talked about, creating a stable wormhole would require a massive amount of energy. Not like a vacuum cleaner, but more energy than that. To give you an idea, we could take every nuclear bomb in the world, harness all the energy from the explosions, and still not have enough energy to form a wormhole. Nonetheless, in theory, the possibility is there. And imagining exploring different points in time is beyond amazing and keeps me up at night, besides ice cream. Novikov's self-consistency principle is a juicy one to say at least. It is a theory that suggests time travel could be possibly without the risk of creating paradoxes. How, you ask? Well, according to this theory, if you were to travel back in time and change something, the universe would somehow conspire to ensure that your actions didn't alter the course of history. In other words, any actions you took in the past were already a part of history, so it would be impossible for you to change anything, such as World War II. The Novick self-consistency principle is like a game of billiards. If you were to take a shot and miss the pocket, the balls would continue to bounce around until they ended up into the predetermined places. It can be a confusing concept, but it could allow time travel without creating paradoxes. It goes without saying that the principle is still just a theory, but it is a fascinating one to consider. Hopefully it doesn't keep you up at night. According to the many world interpretation, the universe splits into multiple branches, like a tree, every time an event happens, creating a multiverse of parallel universes, sort of like Spider-Man. In the multiverse, every possible outcome of every event exists in its own branch. So if you were to go back in time and change something, you wouldn't be erasing or altering the past, you'd be creating a new timeline, like a tree. So time travel in the many worlds interpretation, or multi-universe, is like exploring a vast forest with infinite hiking trails, each leading to a unique and different viewpoint of the same waterfall. No matter which one you take, the rest won't change, unfortunately. I'm curious on that one. If you change something and go back to the future, will the alternative you just be as they are, or are you going to a no universe? Anyway, closed timeline curves. Imagine you're on a roller coaster. Oh, the fun of Six Flags. Flying through the loop-de-loop and going down a Superman. No innuendo right there. As you twist and turn, you feel like you're going back in time, right? Well, that's kind of what happened in a CTC. CTCs are like loops in the fabric of space and time, where you can travel back to an earlier point in time and potentially change the course of history. Exciting, right? It's like a cosmetic time machine. But how does this work, you may ask? In CTCs, the laws of causality get wonky. That means cause and effect don't always happen in the way we're used to, meaning one domino might not hit the logical next one. Instead, events can loop back on themselves and create a causal loop. Now, CTCs are still purely theoretical, of course, but some scientists believe that they might exist in certain regions of space and time, like near a black hole. But whether we can use them to go back in time, or change the course of history is still up for debate, unfortunately. Another one? Imagine for a moment that time is like a river, constantly flowing with no beginning or end. Now imagine that the butterfly flapping its wings is one corner of the world and can create a ripple effect that eventually leads to a hurricane in another part of the world. That's the butterfly effect, not like the butterfly outside. The butterfly effect suggests that even the smallest actions can have a huge, unpredictable consequence. What if we applied it to time travel? What if we could somehow control these ripples? What if we could create our own little waves in the river of time? The butterfly effect suggests that even the tiniest change can have a big impact. So if we could go back in time and make even the smallest altercation, we could create a whole new timeline. Of course, this is all theoretical, but we have yet to discover a way to control these ripples in time, unfortunately. But the butterfly effect offers an intriguing possibility that even the smallest actions can have a huge consequence, which makes us wonder what kind of ripple could we create with bigger actions, like traveling back in time to stop a major event from happening. And if somebody did do that, how do we know other things happen? Like, we know we landed on the moon or JFK died, but what if somebody went back in time and they made it that way? The real danger comes from not knowing what the consequences would be, unfortunately. Still makes you think, if you wanted to change time and stop World War II, maybe somebody did change World War II, and that's how we see it today. Anyway, grandfather paradox. This theory explores the possibility of traveling back in time and potentially changing the course of history itself, rendering our present-day reality unrecognizable. The paradox comes in if you travel in time to kill your granddad before he has kids, then you wouldn't be alive to travel back in time in the first place. You can apply this logic to almost anything. But one way to potentially solve this paradox is through the concept of a parallel universe. In the grandfather paradox, if we traveled back in time and tried to unlive one of our ancestors, we wouldn't eliminate our actual grandpa, but a different version of him. This means we wouldn't be changing our present-day reality, but altering a parallel one. Of course, this theory is purely spectacle, and the existence of parallel universes is still up for debate, but it's exciting to imagine the possibility of time travel and what it could mean for our understanding of the universe. Time as a fourth dimension is another one. Imagine you're standing in the middle of a room. You can move back and forth, left and right, and up and down. But if you could also move forward and backward in time, just as easily as you move through space, that's the basic idea behind the theory of time as a fourth dimension. This theory sees time as just a regular another dimension, like the three dimensions of space we're familiar with. Like you can move in any direction in space, this theory says you can also move in any direction of time itself, which would be really fun. An object's position in space is determined by 3 coordinates, and its position in time is determined by the 4th coordinate. How would time travel work in this theory? Want to travel back in time to see dinosaurs or Egyptians? Just move backward along the time dimension until you reach that area. Want to see the future? Move forward along the time dimension in that parameter. Speaking of which, I saw an interesting theory, which I may do a video on this. If you go backward in time, Earth is different space in the universe, and it's moving along the universe wherever it is, floating in space. So if you went back in time at a certain time frame, you'd have to make sure that you're in the right time coordinates of where the Earth is in space. So if you weren't tuned to that, you'd be going back in time, but then you may land up on another planet or even in the outer space. So just an interesting thought. Anyway, even with the particular challenges, the idea of time as a fourth dimension certainly opens up small possibilities and usually makes the concept easier to understand, which is quite neat. Giant block of ice is another theory. You can see the entire block at once, from beginning to end, with all of its twists and turns, endings and beginnings. Now let's say you want to travel through time. In the block universe theory, you wouldn't actually move through the block of ice. Instead, you would simply exist at a different point within it. This is because the block universe theory poses that time is not a flowing river, but rather a frozen river, with all the elements already set in stone, so you have no free will. If you were to travel back in time, you wouldn't be changing anything that has already happened. You would simply be experiencing it from a different perspective. Seems like a little paradox that you can't avoid, unfortunately. White hole theory is another one. Opposite of the black hole theory, this theory suggests that time travel may be possibly through the use of a theoretical object known as a white hole. It's accepted that a black hole is basically a cosmic vacuum cleaner that sucks in everything in its path, including light and planets and galaxies and all that fun stuff. Its opposite, a white hole, can be a cosmic leaf blower that spits out everything, including matter and energy. Some theories also suggest that maybe that's how our universe was made, from a white hole. According to the theory, if you could harness the energy of a white hole, you could potentially use it to travel through time. The idea is that a white hole could act as a portal, allowing you to enter it and emerge in a different time or even a different universe. White holes are believed to be connected to black holes through a tunnel-like structure called a wormhole. if you're to travel through a wormhole, you can emerge at a different point in time or space. Thanks to the theory of relativity, we know that it is theoretically possible to travel through time via a wormhole, even though you would need special utensils, since it would be opening and closing like your stomach or intestines. Stippler cylinder theory was made by William Jacob von Stockholm in 1936. Brilliant man. Think of a donut-shaped object stretching out into infinity, rotating at high speed. This is the Stippler cylinder. Using this theory, if we could create a cylinder like that and rotate it at a near light speeds, we would travel back in time. To do this, the cylinder would warp space and time around it, creating a path through time and loops back on itself. Such as, if you went out into outer space, Earth would keep going, but you experience time itself in a different manner. So do you age slower? More than likely. Essentially, a version of closed time-like curves is interesting. If we were to enter the path and travel along it, we could potentially end up back in time, allowing us to visit any point in history we deserve or desire, and so forth. Exciting. Interesting matter. I've seen some videos where I think airplane pilots were having their clocks, as it were, while they traveled around the world, and the clocks where they started were slower, unfortunately, or interestingly, because they had a different time variation of how they traveled, which is quite fascinating. Maybe I'll do a video on that as well. Anyway, thanks for watching. Hope you learned a little something, even though all these are theoretical. Anyway, have a great one. Bye.